Okay, worksheet 4.2.1.c is going to be broken up over several days, and so I'm going to also break up the problems that I did in class over several videos so that none of them are too long. And we're going to be breaking them up into the different types of problems. So this first video will cover the first two types of problems, and I'm going to look at number 2, 4, 6, and 8 on the worksheet in this video. So on worksheet B, which is a little bit of a backtrack, so on worksheet B, you guys did an entire worksheet solving equations like this one right here, where the trig function you were looking for was already isolated. You were already given the trig value on the other side of the equation, and the question you were answering is what angles between 0 and 2 pi had that particular trig value. And so in the case of an equation where sine of theta was equal to square root of 3 over 2, what you would have had for your answer is you would have had pi thirds, which is the first angle that has a sine value of square root of 3 over 2, and then of course 2 pi thirds. Now, one thing that I did remind them of is that technically when we came up with these answers here, what we had just done is we had just taken the inverse sine of the entire equation, because when you take the inverse sine of the left side, that's what made sine go away and left theta by itself, and then we just did inverse sine of square root of 3 over 2 and got these two primary answers, because we were only looking for answers between 0 and 2 pi. Okay, and it's not going to be crucial that you do the inverse sine step now. I just wanted to start introducing the kids to it, start talking about it, because later on we are going to absolutely need to know that we did that inverse trig step. So starting on worksheet C now, the first problem I'm going to look at is number 2, and that equation said 2 times sine of theta is equal to the square root of 3. And so all it is one additional step over what you would have done at the very same problem on worksheet B. And that one extra step would be to divide both sides of the equation by 2 to move the 2 off of the left side. Once you had done that, you would have had an equation exactly like you had seen on worksheet B. It says sine of theta square root of 3 over 2, and it still would have led you to these two answers. Okay, so then, let's go ahead and scroll forward. Equation number 4 on that worksheet C says 2 times cosine of theta is equal to negative square root of 2. And so once again, you would have had that one extra step, that one first step, which is to divide by 2. And now you would have an equation that says cosine of theta is negative square root of 2 over 2. Now for right now, as we just did on question 2, we were only answering for thetas in between 0 and 2 pi. And so the answers that we would have generated here would have been 3 pi fourths or 5 pi fourths. But there's a couple of situations that we need to begin preparing ourselves for. One of the situations is that we may not always only solve between 0 and 2 pi. There might be times where they say to solve between 0 and 4 pi. We might solve from negative 2 pi to 2 pi, things like that. And so what we need to do is we need to practice taking these two answers and writing them in what we refer to as general solution form. And there's another situation that we're actually about to have to dive into with questions 6 and 8 that requires that we do general solution form anyway. And so all a general solution form does is, let me give you a little backtrack of an example. It generates a list of angles that all terminate in the same place. So a while back, before Christmas break, when we were first practicing locating angles and doing that kind of thing, I had asked you guys what some of the other angles were that stop at 90 degrees, that terminate at the same place. And one of the answers that kids had given me, or that your classmates had given me, was negative 270 degrees. But that's not the only angle that's going to terminate at 90 degrees with 90. Another one that would terminate at the same place would be 450 degrees, because what it would do is it would go all the way around 360, and then it would go another 90, and it still ends up pointing straight up at 90 degrees. And so we had talked about how the word for that is coterminal. That means they end in the same place. And we had talked about how it is that you generate lists of angles that all terminate in the same place. And so I asked the kids, what would I have to do to that 90-degree angle so that I would keep coming back around and terminating in the same place? And they said, add or subtract 360. Okay? Which is correct. We do attach a variable to it because no one says that I can only come around once. If I want to start here at 90 degrees, I could come around once back to the same place. I could keep going around and around and around, and every 360 that I go around, I just keep ending up at the same place. So this end tells me that I can keep going any number of times that I want to go around, and I start out at 90 and I go around 360 at a time. Okay, so here's the deal. What that means as far as this answer goes is that if our first answer is at 3 pi fourths, okay, or 135 degrees if you want to think in degrees. Okay, any other angle that terminates in that same place would have the correct cosine value. And so what we would do is we need to write it as a coterminal angle. It's a pattern. And the only difference is that we can't say 360 because our angle's in radians. So since we can't say 360, what we say is 2 pi. And so what this equation does right here is it gives us the equation for a pattern, and that pattern generates the list of all of the angles that would terminate at 3 pi fourths. Okay, and then we just do the same thing with the other answer, 5 pi fourths, and then we just put plus or minus 2 pi n behind it, because then it does the same thing. Here's 5 pi fourths. Putting the plus or minus 2 pi n behind it gives me the list of all of the angles that would terminate right there. Okay? Now, for the purposes of question 4, we don't need that general solution. This is our answer for question 4. But like I said, we're doing general solution form because we need to begin preparing ourselves for the eventuality that we'll have different domains to look through, and because we know we're going to have to deal with questions 6 and 8 right now. Okay, and so you'll see why that general solution becomes really important. So then the next thing that I did before I jumped into questions 6 and 8 with the class is I asked them to recall this graph, okay, back from Algebra 2. And so we just did a real quick sketch of it. Your cosine graph looks like this, of course. That's just one cycle. Okay, the cosine graph just keeps on going up and down, keeps going in waves, goes both directions, just keeps on going forever and ever. Okay, and a normal cosine curve, the first cycle starts right here at 0, and that first cycle ends at 2 pi. That's one complete cosine cycle. And then I asked them, I said, ignore the fact that it's trig. So I literally just put my finger over the cosine, and I just kind of tried to make it invisible. I said, if I put a 3 inside of any function with the variable, with x, in this case with theta, what kind of transformation is it going to do to the graph? And fortunately, most of them did remember. It's a horizontal compression by 1/3. And so that means horizontally, your graph is going to become a third as long horizontally. It's going to become much, much skinnier. And so what that means for our cosine graph is that instead of only fitting one cycle between 0 and 2 pi, we're now going to fit 1, 2, 3 cycles between 0 and 2 pi. And so what that means is if I then take my equation and let's say I just set it equal to square root of 2 over 2, on a normal cosine cycle, there are two places where cosine would be square root of 2 over 2. Right here and right here. But on this new cosine cycle, with the horizontal compression, there's going to be 1, 2, 3, 4, 5, 6 places now where our graph hits square root of 2 over 2. And that's because we're fitting 3 times as many cycles in the same amount of space. And so what that means, as far as question 8 and 6, and I'm actually going to go in reverse order here. I'm going to go ahead and do 8 first. 2 times cosine of 3t is equal to -1. Okay. And so what this 3t in here is going to mean eventually is that we're going to be looking for 3 times as many answers, and that we're not going to have to go around 360 degrees or 2 pi between our answers. Okay, so that's why the general solution form is about to become really important. But it's not important in the first step or two. I mean, step 1 is still the same as it was on question 2 and 4. Step 1 is still divide by 2. So I have cosine. And once again, I did a lot of just covering things up with my fingers in class. So I covered this part up because this part's not important yet. The next step is to get rid of the cosine. And so technically what we're doing is we're doing the inverse cosine step of the whole equation to get rid of cosine. But all we're doing is this is our angle. And I just want to know what angles have a cosine value of -1/2. Okay? And so that's where I start out. And so the first angle that has a cosine value of -1/2 is 2 pi thirds. And the next angle that has a cosine value is 4 pi thirds. But then what I have to do is I know now at this point that 3 is about to become really important, because I know that that 3 is not just going to compress my 2 original answers, it's also going to compress how far apart my answers are. So what I have to do is I take the 2 answers that I had so far, I write them as general solutions, and then I do my last solving step. And so my last solving step is to get rid of the 3. Normally we would just say, oh, I'm going to divide by 3, but there's a lot of fractions running through this answer. So instead of dividing by 3, what we're going to say is we're going to distribute through by 1/3. So when I distribute the 1/3 through here, sure enough it gets rid of the 3. I just have t, which is my angle. Then I distribute the 1/3 here, and it tells me that my first answer isn't at 2 pi thirds anymore, it's now at 2 pi ninths. Then I distribute the 1/3 here, and what it tells me is that instead of having to go around 2 pi to get to my next answer, I only have to go around 2 pi thirds to get to my next answer. And then I do the same thing with the bottom row. 4 pi thirds now becomes 4 pi ninths, and 2 pi now becomes 2 pi thirds. And then the last step of the problem is to use these general solutions. Okay, I just want to make sure that we keep using that terminology because you're going to see it soon. So use those general solutions to generate all of the answers in between 0 and 2 pi, because that's what the instructions in the worksheet said, is we were answering between 0 and 2 pi. Okay, so what I do is this. Let me go ahead and switch colors again. I'm going to start with this answer. So 2 pi ninths is my first answer. And then I'm going to add this to it to generate my next answer from that pattern. In order to do that, I need these two fractions to have a common denominator. So I'm going to turn this fraction right here into 6 pi over 9. And now I can actually add it. And so my next answer is 8 pi over 9. And then my general solution form says I can keep adding and keep adding and keep adding, so I'm going to keep doing that. So I add 6 pi ninths again, and now I'm at 14 pi ninths. Now, technically, we're done, but let's just say that we don't know that, because as of right now, we haven't discussed how we know that. Right here, what we would have done is we would have added our 6 pi ninths again, and we would have been at 20 pi ninths. And here's the reason we know that that's not an answer, okay, that we were already done. If our answers are all in terms of pi ninths, then what this domain restriction is telling us is that we're going to generate all of our answers in between 0 and 18 pi ninths, because 18 over 9 is equivalent to 2. And so 20 pi over 9 is too big. And so there's the 3 answers that this one general solution generated. And now we do the same thing with the second general solution. We're going to turn this into 6 pi ninths, so we can keep adding it and keep adding it. Our first answer is 4 pi ninths. Add this, and our next answer would be 10 pi ninths. Add this again, our next answer would be 16 pi ninths. And then we're done, because if we added it again, we would be too big. And so we got 6 answers. Okay? And we discussed one final thing about just the number of answers that we had gotten. When we got to this part right here, if I had just told you cosine of theta is -1/2, you would have just generated 2 answers. You would have generated these 2 answers and you would have been done. Okay? But we threw a 3 in there. And so instead of 2 answers, we got 6 answers. Because that number tells us how many times more solutions we're going to generate. So we can learn to predict how many answers we're going to get. Okay? And then the last one that I'm going to cram into this first video, and just to make you, I guess, feel a little bit better maybe about this, is number 6 and 8, that second row of the worksheet is actually what I think is the hardest row on the entire worksheet. It does get significantly easier from here. Okay? And so question 6 will be the last one that I do on this video. And so, oops, come on. Okay, so that was question 6. Okay, so step 1, still the same as the previous problems. I'm going to divide both sides by 2. Get rid of the 2. Have sine of pi thirds x is equal to square root of 2 over 2. Technically, the next step is going to be that inverse sine step. Remember that most of the time we don't even bother showing it yet. Really, the reason that I keep emphasizing it and bringing it up is because at some point we will begin solving equations that look like this. And that's not a unit circle value. The only way that you can solve that is to go ahead and do the inverse sine, because at that point what you would do is take it out and type it in your calculator. You would do inverse sine of 3/4. Okay, so I just keep mentioning that just so you make sure that you understand that we are doing the inverse trig step even though we're not showing it. Okay, so most of the time, like I said, we don't show that. We just get rid of sine and we figure out what angles had a sine value of square root of 2 over 2. And of course the first one is pi fourths. And then the second one is 3 pi fourths. Okay, and then we're now rid of the sign. Now we need to get rid of the pi thirds. Okay, and we know that the pi thirds is some kind of horizontal dilation because it's multiplying to x. So we know that these two answers that we've already got, they need to be written in general solution form, because when we get rid of this horizontal dilation, it's not just going to mess with our two original answers, it's going to mess with the frequency that our answers cycle. Okay, and so technically the last solving step is to multiply through by 3 over pi. Because when I distribute it here, it gets rid of the pi thirds and leaves x by itself. When I distribute it here, the pi's are going to cancel, and I'm just going to have 3/4. When I distribute here, the pi's will cancel again, and I'll just have 6n. When I distribute here, the pi's will cancel, and I'll get, 9/4. And last but not least, distribute there again, of course, and get 6n. Okay, and then the last thing that I need to do is I'm trying to generate all of the answers between 0 and 2 pi. These answers are still in radians. They're just radians that aren't being measured as portions of pi. Okay, so this is still saying 3/4 of a radian plus 6 radians. Okay, and so what I want to do is I want to figure out if I'm going between 0 and 2 pi, pi is approximately 3.14. So that means I'm generating all of the answers between 0 and 6.28, approximately. And so that's important because with my first general solution, my first answer is 3/4. But if I try to go ahead and add 6 to it, that gives me 6 3/4 as my next answer, which is too big. It's bigger than 6.28. So that means 3/4 is my only answer from that first general solution. And then I go to the second general solution. 9/4 is my first answer. And that's 2 1/4, so definitely too big. If I add 6 to that, that puts me at 8 1/4, which is definitely too big. And so that just means 9/4 is my only answer there. So I only got 2 answers. Well, when we got to this step right here, we had our original 2 answers, and this pi thirds made it look like we were going to have more. But there's a reason that we didn't, and that's because pi is approximately 3.14, and it was over 3 right there. And so our horizontal dilation factor was actually approximately 1. So we didn't end up with 2 times as many answers or 3 times as many answers. We ended up with the same number of answers as we would have originally. They're just not as pretty as they would have originally been. Okay, and that's where we're going to stop for the first type of problem on worksheet C. Go ahead and give those types of problems a try. Get those done before you move on to the next video.